Okay guys, here's the second one. Now, in class we did this. We took a look at the normals. We determined that none of the normals were scalar multiples, which gave us case 3, which meant that it was either no point of intersection, a line of intersection, or only one point of intersection. We then took a look at the triple scalar product. We determined that it didn't equal to 0. Therefore, the normals are coplanar. Therefore, we're either here or we're here. We're not sure which one. So then we assume a line of intersection exists. Okay, so stay with me here. We're going to go through this, and we're going, if there is a line of intersection, we're going to find it, because that seems to be a question on a lot of your minds. You've been asking that. So let's take a quick look. Taking a look at these, I'm going to work with, so I've got 1, 2, 3 equations. I'm going to put these two together, okay, because this coefficient and this coefficient of x are really easy to get rid of. And then I'm going to put these two together. I'm going to get rid of the x variable this time. I don't know what I got rid of last time. I don't care. And that's going to leave me with an equation in terms of y's and z's. And we'll take a look at that. Okay, so I'm going to start with plane 1, which is going to be x minus 5y plus 2z minus 10 equals 0. And plane 2, which is going to be x plus 7y, bring this up a little bit, minus 2z plus 6 equals 0. I'm going to get rid of the x's, so that's going to be 0x. It's going to be negative 12y. It's going to be plus 4z, and it's going to be negative 16 equals 0. This I can reduce, so this can, I'm going to common factor out a 4, so it will be negative 3y plus z minus 4 equals 0. All right, good. We'll call that equation number 4. Now I'm going to work with plane 1, which is x minus 5y plus 2z minus 10 equals 0. And I'm going to work with plane 3 this time, which is 8x plus 5y plus z minus 20 equals 0. I want to get rid of the x's, so what I need to do is multiply one of them by 8. So where's my green pen? This one needs to be multiplied by 8. I'm going to run out of room, so I'll bring it down here. So it's going to be 8x minus 40y plus 16z minus 80 equals 0. And 8x plus 5y plus z minus 20 equals 0. We're going to use elimination here. That's going to give me 0x minus 45y minus 15z minus 60 equals 0. I can reduce this. It'll be negative 3y. There's 3 15s in 45. There's 1 15 in z. That should be plus, I believe. So plus z, and this should be minus 4 equals 0. And we'll call this equation 5. So then I'm going to take equation 5, I'm going to take equation 4, and I'm going to put them together and see what I got using 4 and 5. I'm going to get negative 3y plus z minus 4 equals 0. I'm going to get negative 3y plus z minus 4 equals 0. We'll subtract them. We'll get 0y plus 0z plus 0 equals 0. So, and what I said that meant was that any value of y and z can be used to come up with a point of intersection here, which means that there's going to be a point of intersection. In fact, there's going to be a line of intersection. So we know that there's going to be a line of intersection, okay, because any values of y and z can be used. Let's say it asked you to determine the line of intersection. So what I would do is I'd go back to either one of these, either 4 or 5, pick one of them. Let's go back to 4. Negative 3y plus z minus 4 equals 0. And I'd change it to 3y equals z minus 4. And y would equal minus 4 over 3 plus 1/3 z. That's what that would equal. Now, I like my parameter to be z, so I'm going to say let z equals t, which means that y is now going to become negative 4 over 3 plus 1/3 t. And now what I have to come up with is the parameter for x. So going back up into equation 1, I'm going to say x minus 5y, and y is 4 over 3 negative, plus 1/3 t, and then plus 2t minus 10 equals 0. So this is going to be x plus 20 over 3 minus 5 over 3t plus 2t minus 10 equals 0. X is going to be 20 over 3 minus 5 over 3t plus 6 over 3t minus 30 over 3. So it's going to be minus 10 over t. 10 over 3, sorry. And this is going to be plus 1 over 3t. So x is going to equal 10 over 3 minus 1/3 t. So there's my x, there's my y, there's my z, using another piece of paper. So I'm going to rewrite those just so that we have them. X equals 10 over 3 minus 1 over 3t. Y equals negative 4 over 3 plus 1/3 t. And z equals t. Okay, kids, so this is what I've got. In vector in vectored form, it could look like this. Now, let's see if we can't make it look any nicer. Notice that this point is 10 over 3, negative 4 over 3, 0. If I'm able to, what this really means is I have this point, 10 over 3, negative 4 over 3, 0. I have this direction vector somewhere, negative 1/3, 1/3, 1. I'm going to take that direction vector, I'm going to apply it at this point, and we're going to be moving. So my question is there a value of t that I can add such that 10 over 3 minus 1/3 t can equal a whole number? And it would be the same question as, is there a value, the same value of t, will it change that to a whole value? And, well, that's going to be a whole value. It's going to work out anyway. So let's see. If I allow t to be 1, so in other words, if I go one direction this way, t to be 1, instead of 10 over 3, it'll be 9 over 3. And if t equals 1, instead of negative 4 over 3, it'll be negative 3 over 3. And instead of being 0, it'll be 1. And that will take me to a new point. This new point is simply, so I move down here by moving one scalar multiple of the direction vector, and I was able to change this to a nicer point. Now, to change the direction vector, all I need to do is make it 3 times longer. So that'll be and that is the answer that I expect from each and every one of you. Okay, ladies and gentlemen, I'll see if there's something else I need to do.